Okay, so let's look at question number 2 here. In a large population, 62% of the people have been vaccinated. If 4 people are randomly selected, what is the probability that at least one of them have been vaccinated? Okay, now, we could just go straight to finding the answer, but we'd have multiple calculations. We'd have to consider, okay, 1 of them could be vaccinated, 2 of them could be vaccinated, 3 of them could be vaccinated, 4 of them could be vaccinated. What's easier in this situation is to use the complement. The opposite of at least one of them being vaccinated is that none of them are vaccinated, and that's just one calculation. So let's find the probability that none of them are vaccinated, and then we'll subtract it from 1, and we'll get the probability that at least one of them has been vaccinated using our complement rule. So to figure out that none of them have been vaccinated, let's first note that 62% is our probability that someone's vaccinated, which means that 38%, or 100 minus 62, is going to be the probability that someone's not vaccinated. So 38% as a decimal is 0.38. I'm going to pull up. So we've got 4 people. So our probability that the first person is not vaccinated is 0.38. Our probability that the second person is not vaccinated is 0.38. Third person, 0.38. And then the fourth person not vaccinated is 0.38. And so if we multiply all of those together, we end up getting 0.02085. All right, now I said that we were using the complement because this is the probability that no one is vaccinated. So to get the probability that at least one person is vaccinated, we subtract that from 1. And we get 0.97915. Oops, except I can't type. 97915. There we go. And then, of course, we want to round this to whatever the question asked for back here, 3 decimal places. So, and it said at least 3 decimal places, so we could give it more, the whole thing. Okay, now I think question 3 is along the same lines. Yeah, so it's the same idea as the last one, but let's go to question 4. Suppose you play 3 songs by Jewel, Madonna, and Plum in a random order. Let M be the event that the Madonna song is played first, and B be the event that the Jewel song is played before the Madonna song. Give numerical answers as fractions. Okay, so what is one of the possible orderings of the 3 songs? You got that. Now, part B, how many items are in the sample space? Let's realize that these orderings are what consist of the sample space. So we could have what you had listed here, JMP or JPM. Let's go ahead and put those on my little sheet. So we could have JMP or JPM. That's everything with Jewel first. Now we could have Madonna, Jewel, Plum, or we could have Madonna, Plum, Jewel. And then lastly, we could have Plum first. So Plum, Madonna, Jewel, Plum, Jewel, Madonna. So notice there's 6 in the sample space. All right, so with that in mind, let's go back here and look at our next question. Find the probability of M. Now the event M was the event that the Madonna song is played first. Okay, so if we look back at our sheet, where was the Madonna song played first? Well, in these 2 right here, Madonna is listed first. That's 2 of them where Madonna is listed first out of 6 of them in our sample space. So that's 2 out of 6, which reduces to 1/3. So that's the probability they want on that one. Now let's go back. The probability of B. Now B was the event that the Jewel song is played before the Madonna song. So we want to find among our sample space where Jewel occurs to the left of M. All right, so J occurs to the left of M. So let's look back. So let's see, it does here, there's one. It does here too. Notice it doesn't have to be directly to the left. It doesn't there, and it doesn't there, and it doesn't there, but it does here. So 3 of them out of 6. So 3 out of 6, that probability is a half. All right, well, let's go back. So write the calculation for the probability of M complement. All right, so M complement, we got the probability of M in C. We want to write the calculation for the probability of M complement. Well, I assume that they just want you to show that we're going to subtract from 1 what we got from our previous problem. So we're going to go 1 minus a third. Or they might want you to go into 3 over 3 is the same thing as 1. Of course, we'd get 2/3, but I'm thinking they just want us to show that right there. And actually, we could check just to be sure that that's what they're wanting us to show. 1 minus a third. Yeah. So that's really all they want you to show there. All right. Now, probability of the union of these two events. Now, before we find the union, let's go ahead and do G. And the reason why we're doing G is because the union has the intersection in its formula. So let's find the probability that the two events occur at the same time. So we're looking for the probability that the Madonna song is played first and that the Jewel song is played before the Madonna song. Well, if we think about that, we can't have the Madonna song played first and at the same time have the Jewel song played before the Madonna song, because the Madonna song has to be played first. So this intersection is 0 in G, which is nice. Okay, so we've got the intersection of 0. Let's go back to the union, which we do our union. Our formula for the union is the probability of M union B is equal to the probability of M plus the probability of B minus the probability of their intersection. And instead of going and finding that intersection symbol, I'm just going to use the word and there. Okay, so we already said that really that last calculation was 0. So what we've got is the probability of M was 1/3. And actually, let's go back to 2/6, just because we won't have to find a common denominator. The probability of B is 3/6, and we said the probability of the intersection was 0. So we end up with 5/6. We may add together our two fractions, and there is that probability. And of course, we already said that last one is going to be 0. All right, so let's see. Let's go on here. Watch my time just because it only allows 15 minutes. This one looks like the same idea. Let's go to this one. Okay, so a store purchases baseball hats from 2 different manufacturers in 3 different colors, summarized below. One hat is chosen at random. We want to give our answer to at least 4 decimal places for each of the probabilities. So find the probability that the hat was black or was from manufacturer B. So let's look at black hats first. We have, if we look at this column of black, there were 40 black hats, but we also want to look at those that were from manufacturer B. Now, in this 40, though, we counted 22 of them in this entire row, so we've got to be careful that we've got 40 that are black, but we also have 25 and 11 that came from manufacturer B as well. So we got 40 plus 25 plus 11. And go back to my sheet. 40 plus 25 plus 11. And that's going to be the top of my fraction and my probability. We look at, we look at the total number in our sample. It's 104. So we want that out of 104. So go back to my sheet. So that's out of 104. So let's see, if I add up the top, 40 plus 25, 65, 76 out of 104, if I've added correctly in my head. And I'll stick that in my calculator. 76 divided by 104, it's going to end up being 0.7308. I think it said 4 decimal places back there. All right, now let's go to part B. All right, so find the probability of red complement. Okay, so we want all of the hats that are not red for red complement. So let's notice that we have a total of 40 black hats. We have a total of 40 blue hats. And those are the only ones that are not red. So there's 80 black and blue hats out of 104. So 80 out of 104. Again, we can stick that into our calculator. That ends up giving us 0.7692. Alright, and let's go back. And then let's see, find the probability of manufacturer B and red. Okay, so this means they're occurring at the same time, manufacturer B and red. So if we look at where the entire row for manufacturer B and the entire column for red come together at 11. So we have 11 hats out of 104. So let's do that calculation. 11 out of 104 ends up being 0.1058. Alright, and then lastly, we want the probability that manufacturer B or red. Okay, so we've got hats from either manufacturer B or we have red hats. So if we look at manufacturer B, there's 58 hats in that row. And then we want to put the red hats together with those 58. Now notice though that 11 of those red hats are already in that row. So we don't want to include those again. We have to do the 58 plus the 13 red hats we haven't considered yet. So 58 plus 13 out of our 104. So 58 plus 13, and then we're going to divide it by the 104. Let's see, that gives us 71 on the top out of 104. If I add it correctly, so 71 out of 104, and that gives us 0.6827. Okay, and then was that it on this one? Yes, it was. And I think 7 looks like the same idea. So let's see. Miss Donovan is the coach of a middle school golf team that has 10 golfers. There's 4 6th graders, 2 7th graders, and 4 8th graders on the team. Miss Donovan will randomly select 2 team captains. What is the probability that the captains will be 8th graders? Okay, so we got 2 8th graders. Let's just take a look at, okay, we have 4 8th graders out of 10 golfers. So that's 4 out of 10 for our first choice. All right, so 4 out of 10. I'm running out of time, so I'm going to be my... Now, assume we got an 8th grader. We now have 3 8th graders out of the 9 golfers that are left for the second choice. And if we multiply these fractions, 12 out of 90, and of course reduce that fraction. And let's see, 4 goes into both, into the top 3 times and the bottom 15 times. And if I've reduced correctly, we've got 1 out of 5. And I'll stop there because we're about out of time on the screencast-o-matic.